Since water is a pure substance, it cannot be broken down into other substances by physical processes. Instead, chemical processes must be used. The best process for this purpose is electrolysis, which consists of breaking down a substance using direct electric current. When liquid water is subjected to electrolysis, two simple substances are obtained: hydrogen and oxygen, in a fixed ratio of 2 volumes of hydrogen and 1 of oxygen. For this experiment, you will need a vat, Tupperware or bowl with a large mouth, distilled water, salt, 2 test tubes, cables, a 4.5-volt battery, 2 small stainless steel screws. The screws act as electrodes. Drawing pins can be used, but they may rust. In a laboratory, graphite rods like this one are normally used. Tie the wires to the stainless steel screws. Place the container upside down and screw them on the base. Turn it around and add water until it is approximately half full. Distilled water presents a resistance to current. To reduce this resistance, we recommend using sulfuric acid in this experiment. However, to lower the risk of acid burns, a small amount of salt can be used. With care, fill 2 test tubes in the vat with this solution and place them so that they have no air inside. Now place the filled test tubes on the screws so that the tip of the screw is inside the test tube. Then connect the battery to supply a direct current. Bubbles will appear inside both tubes, and the water level will slowly fall. When not much water is left in the tubes, they should not be completely empty. Disconnect the electrodes. To analyze the results, the volume of gas in each tube must be calculated by measuring the height of the gas in each one. 1. Volume of gas in the test tube with the screw connected to the negative terminal of the battery. Volume 1. 2. Volume of gas in the test tube with the screw connected to the positive terminal of the battery. Volume 2. Finally, note the numerical ratio between the volume of gas contained in each test tube, Volume 1 to Volume 2.